Okay, so this will be a video about polynomials, which is a section of the Additional Mathematics course. By the way, the material covered in this video is also very relevant, or almost completely relevant, to the P2 Chapter 1. So let me just write in the title here, Add Maths, which is the intention, but also P2. Okay, so what do we learn in this section? Let's just go through the main points first. The first thing we learn about is equations and identities. So an identity is not the same as an equation, and you need to understand the difference. The second thing you need to learn about is the definition of a polynomial. Okay, obviously that's important. The third thing is polynomial arithmetic. So hopefully you know that mathematics is not arithmetic. Arithmetic is part of mathematics. Specifically, arithmetic is add, subtract, multiply, and divide. Whoops, interesting divide sign there. So there we go. The next thing you learn about is equating coefficients. So the method of equating coefficients is actually going to link in to how we divide polynomials, because actually that's the only kind of arithmetic that's at all difficult. Okay, having learned that properly, we'll now be able to understand factors and remainders. And we're going to learn what are called the factor and remainder theorems. And the last thing we're going to do, it's kind of fun, is to solve cubic equations. So what is a cubic equation? In case you don't know, that's a cubic, yeah, power 3 or exponent 3. You already know how to solve quadratic equations, so at the end of this section you will be able to solve some, I should emphasize that, solve some cubic equations. So let me just save this document if you don't mind, otherwise I'll be in trouble. Put this somewhere. Okay, so we're off and running. We have basically these few sections to look at. The first couple won't take long, so I'll do them straight away, and then we'll get into the meat of it, which is actually how to work with polynomials. So first of all, equations and identities. So I'm going to start by showing you my PowerPoint file, just to give you a quick rundown of what's going on with these objects. So excuse me, let's get started. Now before we really get into this, I should mention that I will be asking questions during the video, and of course the logical thing for you to do, the sensible thing, is to stop the video if there's a question and make sure you either you know the answer, or at least you try to find the answer. Actually, hold on, I think I've made a slight mistake here. There we go. So try to answer the question basically. So here we go. Identities and equations. Now you already know this word equation. Do you know this word identity? In English it means sameness, or your identity is who you are. a bit of a philosophical question, that. But obviously in maths we have something more specific in mind, something in particular, some particular thing. So look at this equation. First question for you: is it always true? Is that a strange question? Have a think about it. Yes or no, is it always true? Okay, you should almost certainly come to the conclusion, no, it's not always true, because x has to be one value, 1.5. If x is 1.5, then it's true. If it's not 1.5, it's not true. Now look at this equation. Is this one always true? You should probably be of the opinion that yes, it's always true. So we call this an identity, and I want you to look. I'm showing with my mouse here the most important thing: 1, 2, 3. 3 bars. This refers to an identity. So this is an identity, whereas this is an equation. This is always true. Doesn't matter what x and y are. It's always true. This is only true in a certain case. Okay, so that's equation and identity. I hope that's simple enough. Okay, next point. What is a polynomial? Okay, now that might look scary if you've never seen anything like it before, or if you've not studied this kind of thing too much. Here we have the definition of a polynomial as being a sum. This thing here means sum, means plus. We're going to add a set of terms. Okay, the set of terms, each term has a power of x and it has a number with that power of x. And this is called a polynomial in x of nth degree, usually nth degree. Look at the part in red there. This is an nth degree polynomial where n is a number like 10 or 20 or 3, a positive integer. So, before we go on to answer these questions, sorry, I've made a little bit of a mistake there. Getting used to the technology. Before we go on and answer any questions about polynomials, let's make sure you understand what that strange thing means. So let me show you. I need to go back to this one, and now I need to go here. There we go. So on the PowerPoint you saw this expression. Let's write this in black. Sigma ak x to the power k. K runs from 0 up to some number n. Okay, so sigma is a Greek letter. That means sum. So, what are we? So we're adding things. How many things are we adding? The answer is n plus 1, actually. Now let me give you a specific example. K equals 0 to 3. Ak x to the power k would be written as, and this, notice, is an identity. That's an identity. A0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3, or x cubed. Now what are these numbers a0, a1, a2, a3, ak in general? They need to be real numbers, but that's not a very strict condition, right? In other words, they don't have to be integers, they don't have to be positive or negative, and they can be 0, but one little exception here, a3 is not 0. Because if a3 was 0, we would just get rid of that term there, and we would just write these 3 terms here. So, example. So I'm getting more and more specific, so it's really clear what I mean. This is a polynomial. 7x to the power 3 minus 6x to the power 2 plus 0.1x minus 107.8 is a polynomial. Degree of the polynomial is 3. Now what does degree mean? It's very simple. The degree is the number there. And now what is this number telling us? It's telling us the power of x which is highest. Yeah? So we're on from 0 up to some maximum. Whatever that maximum number is, that's the degree. So that's the definition of degree. So now you should have some idea what a polynomial is. I'll just write two more. 17x minus 11. That's a polynomial because that's power 1. So that's degree 1. 84x to the 10 minus 3x to the 6 plus 17x to the 22. What's the degree of this polynomial? Yes, the answer is degree 22, because this power 22 is bigger than this one and this one. So that's how we talk about polynomials. Notice from this example, you don't have to have every single number going down from 22 to 0. You don't have to have x to the 22, x to the 21, x to the 20, and so on, so on, so on, down to x to the 1 and x to the 0. No, you don't have to have that because these numbers are allowed to be 0. It's only the highest one which is not allowed to be 0. Also notice that in this example, degree 1, we have a constant term. What is the constant term? Well, the constant term corresponds to x to the power 0. Yeah? Because 11 can be written as, excuse me, just writing this on the side, 11 could be written 11x to the power 0, or rather minus 11 could be written as minus 11x to the 0, because x to the 0 is 1, always, for every value of 1, so that again is an identity. Okay, I'm just going to erase that because that's a bit messy, isn't it? So there we are for now. We have the basic idea of a polynomial. Now this will be expanded a bit further on the PowerPoint, so let's have another look. Okay. So nth degree polynomial. Now if the degree of the polynomial is 0, what does that look like? What is that object? Again, try and answer every question that's asked. Pause the video if necessary, as you like. So the answer here is a constant. Because if the degree is 0, that means that number n is 0, which means we're going from 0 up to 0, which means we're just having one term, a is 0, x to the power 0. Now, as we just said, x to the power 0 is 1, so a0, the constant a0, is what we get. What kind of polynomial is a quadratic? A quadratic function, you should know that. The answer is that's degree 2, because x squared, or x to the power 2, means that n is 2, means that the polynomial has degree 2. Now let me show you this. Is this a polynomial? Have a look at this. Is that a polynomial? What degree or order is it? Order is the same as degree. So the answer is, the answer is 4. The degree is 4 because the highest power is 4. Simple as that. This, on the other hand, is not a polynomial. Why not? Well, because sin x is simply not of this form. So not every function is a polynomial. It has to be powers of x. And moreover, the powers of x cannot be negative. If we had x to the minus 2, that would not be a polynomial. So here is a graph of a typical polynomial function. Maybe you can't quite see it. It says x to the power 5 plus 5x to the power 3 plus 4x. It's just a typical example. Drawing graphs of polynomials is not simple when the degree is high. And you certainly won't be expected to draw lots of different graphs of polynomials at this stage. So don't worry about that. Okay. So now let's go back to the beginning. Let's see how far we've got. Going back to the first page. So let's have a little inventory here. We've oh, excuse me, my Windows is annoying me. Let's have a little inventory here. We found out the difference between equation and identity, and we know the definition of a polynomial, so that if I give you a function, you can tell me if it's a polynomial or not, and you can tell me its degree. So far, so good. Now let's think about polynomial arithmetic. Okay, polynomial arithmetic. First of all, some easy, obvious things. Plus and minus. Let's think about adding. Here's one polynomial. Notice I'm writing it as a function. Now I can write identity here, but it's probably not necessary. 3x to the power 3 minus 6x squared plus 10. By the way, this is sometimes called a cubic polynomial because it's degree 3. So cubic for a degree 3. I'm going to write another polynomial now. Qx 6x squared minus 7x minus 7. What kind of polynomial is this? That's right, it's quadratic. It's degree 2. Degree, here just DEG for degree, okay? Degree 2. So, and I know this is ridiculously basic, so I apologize if it seems silly, but if we add them together, what do we get? Obviously we just simply add the similar terms. So this has no corresponding term here. I get 3x cubed. This and this add together to give 0. Then I get minus 7x and I get plus 3. So that's easy, and the basic idea is to add the terms of the same degree or the same power. Now obviously if I subtract, well, I just do the same thing. 3x cubed, what's this, minus 12x squared plus 7x plus 17. Okay? Now, although that is very obvious, you should at least think a little bit about the question of degree. How is degree impacted by adding or subtracting? In these cases, px plus qx has degree 3, and px minus qx also has degree 3, which was the degree of p, right? So you may think, well, therefore, the general rule is the degree of px plus qx is the highest of the degrees of p and q, and that is usually true, but there is an exception to that rule if you think about it. But hey, it's not very interesting, and it won't affect anything that we do going forwards very much. So I won't talk too much about that. Slightly more interesting, but still quite easy, is multiplication. What happens if we... So I should actually put minus here as well. What about multiplication? If we multiply px by qx... Now we don't want to do this because it's a bit boring, isn't it? Let's just write it out. 3x cubed minus 6x squared plus 10 times 6x squared minus 7x minus 7 equals dot dot dot. Now why do I say dot dot dot? Because obviously it's not very much fun. Why isn't it much fun? 1, 2, 3, 4, 5, 6, 7, 8, 9 cross terms to calculate, yeah? So lots of work to do here. And then here, oops, here, and then here, and so on and so on. Nine cross terms. But let's have a little question without actually doing it. What's the degree of PQ? What's the degree of the product? Without actually calculating it in total, we can easily see, can't we? Is it, for example, look, degree of P was 3, degree of Q was 2, so is it 3 times 2 equals 6? Is that the right answer? Think about it. No, obviously not. The answer is 3 plus 2. 3 plus 2 equals 5. The degree of the product is x cubed times x squared is x to the power 5. So what's the rule here? The degree of the product is the sum of the degrees of the individual polynomials. So here was a 3, here was a 2, we add them together and that gives us the right degree. And why is that? In case it isn't obvious, it's because x to the 3 times x to the 2 is equal to x to the 3 plus 2. That's the rule of exponents, or the rule of powers. So we've already learned something that we're going to find very useful later, which is what is the degree of the product of two polynomials. Now let's get on to polynomial division. Let me just save here and move to my other window. Let's get on to polynomial division. This should be more interesting, I hope, for most people. I might just have to go through some before we do that, let's just go through some basic definitions. If we have degree 1 like that, we call it linear. That's a linear function. You should already know that. Degree 2 is quadratic. Sorry for that printing error there. This should say some quadratic function here. Now degree 3 is called cubic. Degree 4 is called quartic, and degree 5 is called quintic, and so on. But we don't really need to worry about these. Just remember cubic for degree 3. Now what's the degree of this polynomial? You should see the answer is 6. This is written in descending order because the highest power is first and it goes down. This is the same polynomial written in ascending order, and this is sometimes called unordered if we don't bother about the order of the powers. But of course it's the same polynomial in every case. Right, now before we go on to learning how to divide polynomials, and yes, I'm sure some of you think you already know how to do it, but I'm going to teach you a different way. In order to teach you that, I need you to understand one very important, powerful idea. Look at this rather complicated looking identity. Actually, it's an identity. What's this? This is a polynomial. What's this? This is another polynomial. They're different. How are they different? How are they the same? They're different because here it says AK, here it says BK. In other words, these numbers, which we call coefficients, by the way, are not the same. Or are they? This number n is the same. So what is the same about these polynomials? They have the same degree. Now what's more, we have identity. What does that mean? Let's look at this in a little bit more detail. It means that it's easier to see with this example. If this says identically equal, that's very, very important. Think about it carefully. If this just said equals, here we have a function of x, here we have a different function of x, and they're equal, well then our job is simply to find the value of x, which makes them equal. But it doesn't say that, it says identically equal. And what you should think of that as meaning is that x can vary, x can go up, x can go down, x can change to a different number. It's still true, it's always true. Now if it's always true, then it must be the case that every one of these numbers, 3, 4, minus 10, minus 60, is the same as the corresponding number for the right hand side. So A must be 3, B must be 4, C must be minus 10, and D must be minus 60. If that's not obvious to you, it doesn't mean you're stupid. It isn't necessarily completely obvious, but unfortunately I don't really want to go into a kind of step-by-step proof of it because that takes up time. If you look at very simple examples such as straight line functions, you'll see quite easily why it should be true. And then hopefully you'll see why it should be true in any polynomial. Now So let's just backtrack a minute. What are we saying here? This is the method of equating coefficients. Coefficients are these numbers, 3, 4, minus 10, minus 60. And they're written as a, k, and bk here. And what we're saying is precisely because, and only because, we have these 1, 2, 3 bars here, it means that we get 1, 2, 3, 4 equations from this single identity. So one identity can give you more than one equation. It can give you many equations. Now, why 4 equations? Because here there are 1, 2, 3, 4 coefficients involved. This is why the idea is so powerful. From only one identity we get 4 equations, or 4 pieces of information. And this power, this great amount of information, is what will allow us to divide polynomials very easily. Okay, so now it's all going to come together. All the things that we've learned so far: identity and equation, coefficient, degree, all those concepts will come together and allow us to divide polynomials easily. Here we go. So, division. Let's look at one typical division problem. Okay, 2x to the 4 plus 3x cubed minus 5x plus 5, and I think I'll do this on the written notepad so you can see me doing it in real time. It's not a particularly easy one, but it's not very hard either. So first let me write down 2x to the... Why have I got... that's interesting. So let me start it here. So I'm dividing 2x to the 4... Sorry, I just have to go back. 3x cubed minus 5x plus 5 dividing it by x squared minus 8. So, let's consider this problem in a very sort of general way. Let's say that this function over here is called a of x, and this function here is called b of x. Now we know they're both polynomials, so let's take a moment and write down their degree. What's the degree of the left of the object here of a? Degree of a is 2. Sorry, I hope you're awake enough to notice that silly mistake. The degree here is 4, and the degree of b is 2. Okay. Now let's think about what it means to divide. When we divide numbers, we do something like this. I might take a number like 27, and I might divide it by 6. So when I'm doing that, what kind of answer am I expecting to get? Well, I'm expecting to get a single integer number, and then plus something that's called, in English, a remainder. So here the remainder is, I hope you can see, 3. And of course we need to include the divisor there. And at this point I want to remind you, or if you don't know, tell you the English names for all of these things. That one is called the remainder, and this number here is called the divisor. It's the thing we divide by. Obviously it's also appearing here. And this one obviously is a very important one because this is the answer, isn't it? This is called the quotient. Okay. Now I think this one is sometimes called the dividend, but you will very rarely see that word, so it doesn't really matter. But I want you to notice something important. A division can also always be written as a multiplication. What do I mean by that? I simply mean that we can rewrite this statement as this statement. 27 is equal to 4 times 6 plus 3. So we have the same 4 numbers, the dividend, the quotient, the divisor and the remainder, but here they're written as a multiplication, and that's something that's much easier to work with. So I want to make a note here. We don't need to use the method called long division, which is a kind of old-fashioned method which doesn't really help us to understand what's going on. It's more like a machine. I find it's better for us to use the method I'm going to show you now. Okay, now before we go any further, let's take a notice of something important. When we look at the number 3 here in this equation, we know that when dividing by 6, this number, this remainder, cannot just be anything. Here it's 3. Now it could be 0. For example, I could write 24 equals 4 times 6 plus 0. It could be 5. 29 equals 4 times 6 plus 5. So depending on this number varies, but its range of values is 0 up to, that's right, 5. It can't be higher than 5. It can't be 6 or higher, because if it were, that number would then feed back into the quotient. So you notice that this number is restricted in its possibilities. And you're probably thinking this is all crazy. Why is he talking about dividing numbers? I mean, we're not back at primary school. Why are we talking about this? Well, you're going to see that this pattern proves to be very useful. So now let's look at how this applies. This pattern applies to the division up here. Now again, I'm not going to write it as a division, I'm going to write it as a multiplication. I'm going to write 2x to the 4. Oops, let me just change my colour. 2x to the 4 plus 3x cubed minus 5x plus 5. What's this? Identically equal, yeah? To what? To the quotient, which we're going to write as q of x because we don't know what it is, yeah? Times here, you see, that was the quotient. This was the divisor. There it is, divisor. What's the divisor? That's the divisor. X squared minus 8 plus what? Plus the remainder. So we have this rather strange looking multiplication. Now it's an identity. That's very important. That means that if 2 is the coefficient of the 4th power of x here, then 2 will also be the coefficient of the 4th power of x here. But now let's consider degree. We already know that a, which is the dividend, the starting point here, has degree 4. Well, that means this whole thing has to have degree 4, doesn't it? But what's less obvious is that Rx, which is the remainder, follows the same pattern as with numbers, but in degree. Okay, the degree of the remainder must be less than or equal, just as this was less than or equal. Let me get that right. Not less than or equal to, less than. Strictly less than, actually less than, just as this was actually less than 6, the degree of Rx is less than the degree of Bx. What's Bx? Bx is the divisor, okay? Because look, it's the thing we're dividing by. So the degree of Rx is less than the degree of Bx. The degree of Bx is 2. So if the degree of Rx is less than 2, then Rx has degree 1 or 0. Let me just make a bit more room. So the degree of Rx is 1 or 0. So Rx is a linear function, ax plus b. I want you to try and really focus your mind on that step of logic. It's very, very important. The degree of the remainder is less than the degree of the divisor. The divisor is x squared minus 8. So if the degree of Rx is less than the degree of that, then Rx is in general ax plus b. It's possible that a is 0, in which case Rx is just a constant. So let's feed this fact, this very important fact, into our equation. Here we go. So now we have 2x to the 4 plus 3x cubed minus 5x plus 5 is identically equal to qx, some quotient we don't know yet, times x squared minus 8, plus a linear function ax plus b. Now, back to the drawing board. We know the degree of the left-hand side is 4. We know that this is a linear function, and we know that this must have degree 4, yeah? Because this only has degree 1. So how can we get degree 4 here? So degree of qx must be what? Do you see? We need degree 4 here. The answer is 2. The degree of qx must be 2. So that tells us that. There it is. So if the degree of qx is 2, we can write this identity in this way. 2x to the 4 plus 3x cubed minus 5x plus 5 is identically equal to ax. Oops, I need to use different. I'll change the letter names. Hold on. Ax squared plus bx plus c times x squared minus 8 plus, let's say, dx plus e. Sorry, so I hope that wasn't too confusing. I'm going to change that to dx plus e. Now at this point, people who are not used to dealing with identities find this very strange, because you're thinking, oh my god, look, a, b, c, d, e, we don't know any of these numbers. But that's the beauty of identity. Identity, when the power is 4, means 5 equations. There's an equation for power 4, an equation for power 3, an equation for power 2, which is 0 here, equation for power 1, and an equation for power 0. So we get 5 separate equations. Look at this. X to the power 4. Let's consider this on the left-hand side. What is it? It's 2. So the coefficient of x to the power 4 on the left-hand side is 2. What's the coefficient of x to the power 4 on the right-hand side? Well, it doesn't appear here. It only appears in this product, doesn't it? In this product, ax squared times x squared is ax to the 4. So the answer is just a. There is no other way to get x to the power 4. We multiply this one by this one. Now if you want to, some people might find it helpful to actually multiply out this entire product here. Okay, there's going to be, 6 separate terms. So you can do that if you want to. Or you can just follow along with what I'm doing here. Now if I look at the coefficients of x to the power 3, I'm going to get more information. On the left-hand side, I have a 3. And on the right-hand side, now this is a bit more tricky, isn't it? Where can I get x to the power 3? That times that? No. That times that? Yes. bx cubed, that's giving me 3 equal to b. So you see I already have the values of a and b. All I need to do now is find c, d and e. So now I'm going to check the coefficient of x to the power 2 on the left-hand side. On the left-hand side, there's no coefficient of x to the power 2. It's missing, do you see? So that's 0. On the right-hand side, however, there will be some. I'll get minus 8a. You see, minus 8ax squared. And then I'm going to get plus c. So I'm going to get the following. I'm going to get 0 is equal to c minus 8a. Now a is 2, so that's 16. So c is 16. And you see how very easily we get the values of all the constants we need just by going step by step. The coefficient of x to the power 1 on the left-hand side is equal to, you see it, minus 5. And on the right-hand side, this is going to get a bit more tricky, I think, because, okay, so it's just d, isn't it? Yeah, so we just, no, hold on. On the right-hand side, we get x to the power 1 from minus 8b, but also from d. So it follows that minus 5 is equal to d minus 8b. So this will give me the value of d. d is equal to 8b, which is 24 minus 5, so d is 17. And the final step will be to find the coefficient of x to the power 0. Remember, x to the power 0 is 1, so what we really mean is the constant term. Here the constant term is 5, and on the right hand side the constant term is minus 8c plus e. So it follows that e is 8c, which is 8 times 16, which is 8 times 16, is that 128, I think. Did I get that right? 8 times... Yes, of course it must be 128. So we actually have the entire answer. 2x to the 4 plus 3x to the 3 minus 5x plus 5 is identically equal to ax squared plus bx plus c. That's 2x squared plus 3x plus 16 multiplied by x squared minus 8 plus 17x plus 128. And this is the division, because this quantity here is the quotient, and this quantity here is the remainder. And we can apply this method for any polynomial division at all. Usually it will be much easier than what I've just shown you. So I'm going to stop the video now, and in part 2 we will continue to consider the factor and remainder theorems, and then see how we can solve cubics. So at the moment we're going through this. So I'll talk about factors and how we can find factors and remainders very quickly, and then finally we'll talk about how to solve cubic equations. So see you next time.